Hey there, Science 9 again. So today we're also going to be looking at the lab trends in reactivity across the periodic table. Specifically, we're looking at periods or columns 1, 2, and then moving across 13 and 14. So we're going to look at how there's differences in how reactive an element is depending on its position, depending on the column that it's in. To start with this, I think it's really useful to look a little while at the Bohr diagrams again, and especially paying attention to the valence electrons. So let's have a look. So lithium and sodium, you see right here, you're probably aware by now, these are alkali metals. They've got, the first shell is full with 2 electrons, but then the key thing that's same between them is they both got 1 valent electron. Beryllium and magnesium are called alkaline earth metals. We're going to look at reactions involving magnesium today. Notice that they've got 2 valence electrons. Here's boron and aluminum. They're in the same column, just one period separate from each other, with 3 valence electrons. And finally, we get to carbon and silicon. Both of them non-metal. They're not. Neither of them is a metal. They're solids, not very reactive, as you can see, with 4 valence electrons. We're going to look at the trends for how reactive these elements are with water, how reactive they are with acids for this lab activity. We're also going to look at what sodium does, but we're not going to do that here in the lab. We're going to go outside for that because of the safety risks associated with using sodium. So starting with where we're at here, I'm also going to demonstrate for you carbon. In each of these test tubes we have about 20 milliliters of water. I'm going to react magnesium, aluminum, where I'm going to add magnesium, aluminum, silicon, and then carbon to water to look for any evidence of a reaction. Then I'm going to do the same thing for the acid. I changed the acid around. It's not 1 molar acid, it's 3 molar acid. I think we'll get a better result that way. So let's first of all add some silicon to the water. Evidence of a reaction would be any kind of bubbling. Just as so far we're not seeing anything, but we'll come back to that. This is a sample of aluminum metal foil. We're going to add that to the water. And then I'm going to get out a sample of magnesium metal strip. So I've just added that to the water, and we'll come back to all of those. I'm now going to add the silicon to the acid. This is a high concentration acid. If acid reacts with silicon, we're expecting it's going to happen now. The next 2 reactions, I'm going to do these in the fume hood. So this is our sample of aluminum foil, or a sample of aluminum foil, and here's another sample as well of the magnesium metal strip. Go over here. So, adding the aluminum to the acid, and then adding the magnesium to the acid. Might be difficult to see. I think I will have to open the fume hood. But immediately, when I added the magnesium to the acid, we had a reaction right away. We're starting to see possibly something happening with the aluminum. Let's get back to that in a little bit. Looking now at, as well, carbon. There's carbon and water. I'm also going to add this little bit of carbon to the acid back here. Now let's look to see what things are doing and what's happening in the water. For the